Hello everyone, welcome to the GATE NPTEL lecture course. Today we are going to solve some problems from GATE 2019 exam. This is the question number 29. In this question, it was given that a solid cylinder of radius r has a total charge q distributed uniformly across its volume and it is rotating about its axis with an angular velocity omega. What is the total magnetic moment of the cylinder? So we have to find out the magnetic moment of the cylinder. So the best way is if you think of cylinder as a form by the slice by slice of disc. So instead of taking cylinder as a whole, we can take it as a disc. So we are consider a non-conducting disk of the radius r with uniform surface charge density sigma. And it is given that the total charge q is distributed uniformly across its volume. So the total charge on the disk Q is sigma into area A, which is sigma into pi r square. Now we have to calculate what is the magnetic moment of this disk. We know that the magnetic moment mu is given by I into A. I is the current flowing through the disk, A is the area of the disk. Now to calculate the magnetic moment, what we consider is the disk is made up of these small rings, and we know that when the ring is kind of rotating with an angular velocity omega, a current will start flowing through the ring. And the current di is then given by dq by t. dq is the charge onto that ring, and t is the time period of rotation, which is given by 2 pi by omega. So dq is given by sigma into the small area of the ring, since the radius of the ring is small r with a thickness dr. We can consider, so therefore dq is given by sigma 2 pi r into dr. So the current di is sigma into 2 pi r dr by 2 pi into omega. So sigma omega dr. Now, since a disk is made up of forming a lots of numbers of ring up from small radius 0 to capital R. So if we integrate the di from 0 to capital R, we will get the total current that is flowing through the disk. And since the magnetic movement PQ is given by di into pi r square. The pi r square is the radius area of the ring. So this is our magnetic moment of the ring. Magnetic moment of the disk is integration with respect to 0 to r pi omega sigma omega r cubed to dr. From this integration of the expressions, we will get pi by 4 sigma omega r to the power 4 omega. But since in the options, answer is given in terms of q, so we replace sigma pi r square by q, and we will get the magnetic moment in terms of q. It is 1 by 4 q r square omega. So 1 by 4 q r square omega. So this is the correct option here.